Hello Year 12 and welcome to the first video here for our Easter revision. We're going to begin with some algebra because it is the basis of everything that we do. I've copied some past HSC questions in here. I'm not going to work through all of these in this video. It would take rather too long, but I would encourage you to work through them in your own time afterwards. I've circled a couple of questions here we want to look at. A few different things that might be a bit rusty. We're going to begin by rationalising the denominator of this fraction here, right? 1 over root 5 minus 2. You can see I've written it down here already. How organised. Now, we rationalise the denominator. We need to get rid of any surds in the denominator, and we do that here where we have a binomial denominator. That's two terms. We do that by multiplying the top and bottom by the conjugate, right? That is that same binomial with the sign in the middle changed over. So this is going to be multiplied by root 5 plus 2 over root 5 plus 2. Yep. Okay, multiply the top and bottom by the same thing. Doesn't change the value, right? I'm just multiplying by 1 essentially. Now at the top, the numerator, that's fine. Root 5 plus 2. The denominator, well, we should be able to recognise this as the factorisation of the difference of two squares, right? Remember, a squared minus b squared, right? A squared minus b squared factorises to a plus b, a minus b. So here's my a, and here's my b, I guess. So we do the reverse here. I could expand that out using that FOIL method, but I get root 5 squared, which is 5, minus 2 squared is 4. 5 minus 4 is 1. I don't need to put that there. So this is simply root 5 plus 2. There we go. How neat. Next up, question 35. We have a non-monic quadratic. Let me just have another look here. 3x squared plus x minus 2. Plus x minus 2. We want to factorise this. Now remember this PSF method, which might be helpful for a non-monic. That is, the coefficient of the x squared term is not a 1. A non-monic quadratic, we're going to look at this P, S, and F. Product, sum, and factors. So my product is this multiplied by this is negative 6. My sum is this coefficient here is plus 1. My factors then, right, I'm looking for two numbers that multiply to negative 6, that add to 1, and I think that must be 3 and negative 2. So now I rewrite this as 3x squared plus 3x minus 2x minus 2, right? And you see how, if I were to simplify this, I would get back to plus x, right? Now I can group by pairs, so I can take a 3x out of the first two terms, and I get 3x outside of x plus 1, and I can take a negative 2 out of these, and I get x plus 1. How nice. So now I can sort of factorise that again, and I get 3x minus 2 outside of x plus 1, and that's factorised. We don't go any further, we don't solve this, it's not equal to 0, we're just factorising it, and that's it, factorised. Okay, let's look at the next question here, and we have question number 39. Ooh, an absolute value equation we have to solve. So 3x minus 1 equals 2. What was that question number? 39. Question 39. Now we have the absolute value of 3x, was it minus 1? 3x minus 1, absolute value equals 2. Now, this absolute value makes whatever inside positive. So essentially, what we might have between these absolute value bars is it could be equal to 2 or negative 2. If that were negative 2 inside, the absolute value would make it equal to positive 2. So there are two solutions to this. So we have 3x minus 1 equals 2 is one solution, which we'll solve. And we also have, let's say, or 3x minus 1 equals negative 2. That's our other solution. So this means over here that 3x equals 3 and x equals 1. And over here, I can add 1 on, and I get 3x equals negative 1 and x equals negative 1/3. And they're my two solutions to that question. Over here looks a bit interesting. It's asking us for integers a and b such that the square of this is equal to a minus b root 2. So let's have a look. Question 46. We have 3 minus root 2 squared. And I need to express that in the form of a minus b root 2. So let's expand this out. Now this is a perfect square, and this is something that we, oops, my pen's gone funny. Hang on. This is a perfect square, and it's something we're not great at, right? We need to be better at expanding these out. Now, perfect square. Square the first, 9. Multiply the two things together, I get negative 3 root 2, and double it is minus 6 root 2, and square the last, right? Plus square the last. So root 2 squared is 2. That's a plus 2. Again, you can use the FOIL method, but you just need to be able to do it without that. Now I can tidy that up a little more, and I get 11 minus 6 root 2. And if that's the case, then A equals 11, and B equals, we'll be careful here, B equals 6, not negative 6, because it's minus B there, right? So what do I replace the B with? I replace it with 6. And that is the solution to question 46. Right here. A little unconventional, I suppose, slightly different. The wording might throw you out, but look, that's all you do there, is to expand it out, tidy it up, and what we say, we equate those coefficients, or something very much like equating coefficients anyway. Now, question 48 is the last of this video. Question 48, what are we going to do here? I just need to simplify this algebraic fraction. Certainly seems straightforward enough, and you know, you may very well have been able to do this before you began this course, right? Before you begin year 11, you should be able to do this. However, look, we get a bit rusty. So I have 2 over n minus 1 over n plus 1. To add or subtract fractions, I need a common denominator, and to do that, I need to find the lowest common multiple. In this case, I'm going to multiply the top and bottom of this fraction by n minus 1. So this is going to be 2 outside of, oh, not n minus 1, n plus 1. And I'm going to multiply this top and bottom by n. I'm just going to say minus n, because that's negative 1 times n. And that means that I am over a denominator of, we could say n outside of n plus 1. Rightio? We'll expand this out and tidy it up a little. Up the top here, I'm going to have 2n minus n is n plus 2 over, whether we have n squared plus n or n outside of n plus 1 doesn't make much difference. I think I'm going to leave it in the factorised form, n plus 1. You want to be careful that you can't expand that out and then simplify it somehow. This is factorised, and neither of these two factors are n plus 2. This doesn't have any more factors, n plus 2. So that's not going to simplify any further. That's done. That's the end. 2 marks for that, right? It's pretty good, 2 marks. Rightio. That's it for our algebra video. It's 8 minutes. 8 minutes is quite long enough. There's quite a lot of nice sort of questions there to look at that might be rusty. Some of them are calculated questions, some are rationalising denominators. There are some inequalities there that we didn't look at. Just some other things that I'm going to mention because I like to rabbit on, where we have an inequality that is a quadratic. Remember, what you want to do is sketch this, right? Sketch that parabola on a number plane and see where it's less than 0. See where it's below the x-axis. All good? Rightio. So push on with those. Shoot me any questions. I'm going to be interstate, but nonetheless, I'll have my laptop with me and I'll be checking it out as we go along. Okay, hope you enjoy. See you in the next video.